Bismillahirrahmanirrahim. Assalamualaikum students. This is your chemistry teacher Farzana Nazir. Today we are going to continue chapter 5, physical states of matter. Today we are going to discuss Boyle's law, applications of Boyle's law, and at the end of this chapter we are going to practice some numericals related to Boyle's law. Now, after going through these topics, students will be able to explain the concept of Boyle's law. They can account for pressure volume changes in a gas using Boyle's law. Boyle's law. The relationship between volume and pressure was presented by Robert Boyle, and this law is called Boyle's law. Boyle's modified barometric tube into a J-shaped tube. By adding mercury to the open end of the tube, he trapped a small volume of air in the sealed end. He studied what happened to the volume of the air as he added more mercury to the open end. Boyle, from the studies, discovered the pressure-volume relationship. Now, let us observe an experiment related to volume and pressure relationship. A syringe is filled with air. The tip of the needle is sealed in order to contain the air in the syringe. If we push the plunger, it will move only to a certain point before stopping. What caused it to stop? When the plunger is fully extended, the air molecules, which are in the form of gas, are spread out in the syringe. When we push the plunger down, the pressure inside the syringe increases. Molecules move closer to each other. At a certain point, molecules cannot move any closer. We cannot push the plunger any further. This relationship of pressure and volume was explained by Robert Boyle, and it is known as Boyle's law. Boyle's law states that the volume of a fixed amount of a gas at a given temperature is inversely proportional to applied pressure. That means if the pressure on a fixed amount of a gas is increased, volume decreases. On the other hand, if the pressure on a fixed amount of a gas is decreased, volume increases. Mathematically, Boyle's law can be represented as P is inversely proportional to V. P is equal to 1 over V constant. The product of pressure and volume should always be a constant value. So PV is equal to constant. Very often Boyle's law is used to compare the two situations before and after. In that case, we can say P1 V1 is equal to P2 V2. Now let us apply the Boyle's law on a fixed amount of a gas which is trapped in the cylinder. The cylinder is fitted with a movable piston. The external pressure is 1 atmosphere. We can increase the pressure by adding weight on a piston. Suppose the pressure on the piston is increased by 2 atmosphere. As the pressure on the gas increases, the volume of the gas decreases and will continue to decrease until the pressure of the gas equals to the external pressure, or it is equal to 2 atmosphere. The volume occupied by the gas will be half of its original volume. You can see volume is inversely proportional to pressure. As the pressure on the gas decreases, the volume that the gas occupies increases. The volume of the gas keep on increasing until the pressure of the gas equals the atmospheric pressure, which is 1 atmosphere. Now let us do some applications of Boyle's law. Example 1. Ethene is used as anesthetic gas. The pressure on 2.5 cubic decimeter of ethene changes from 1.05 to 2.10 atmosphere. The volume of ethene becomes 1.25 cubic decimeter if the temperature remains constant. Explain this change using Boyle's law. First, we will write the data. P1 is the initial pressure of on ethene, that is 1.05. P2 is the final pressure, that is 2.10 atmosphere. Initial volume of ethene was 2.5 cubic decimeter and the final volume of ethene is 1.25 cubic decimeter. Now according to Boyle's law, P1V1 is equal to P2V2. We will multiply the values of P1V1 and we get the answer 2.622. Multiplying P2V2, again we get the same answer, that is 2.62. Since both the values are same, therefore the data satisfies Boyle's law. Now let us solve another example of Boyle's law. A student obtained the following data in an experiment. Explain PV relationship using this data. Now, according to the data, as the pressure of the system gradually increases, the corresponding volume of the system gradually decreases. It means there is an inverse relation between pressure and volume. To check whether the data satisfied Boyle's law, we are going to multiply the values of pressure with the values of volume. If we get the constant value, it means the data is according to Boyle's law. Now, if we multiply 0.350 with 0.707, the multiple of P and V is 0.24. And if we multiply the value of 0.551 with 0.450, again we get a constant value, that is 0.24. If we multiply 0.762 with 0.325, again we get 0.24. It means that the multiple of P and V is a constant value. Therefore, this data obeys Boyle's law. Example 3. Ammonia gas is used as refrigerant. 0.47 atmosphere pressure is required to change 2000 cubic centimeter sample of ammonia initially at 1.0 atmosphere to 4.22 cubic decimeter at constant temperature. Show that this data satisfies Boyle's law. Now this is a tricky one. According to the data, initial pressure is 1.0 atmosphere and final pressure is 0.474. Initial volume is 2000 cubic centimeter and the final volume after applying pressure is 4.22 cubic decimeter. To get the same units, we are going to convert 2000 cubic centimeter into cubic decimeter. Therefore, we will divide 2000 by 1000 and we will get the answer 2 cubic decimeter. Now, according to Boyle's law, P1V1 is equal to P2V2. We are going to multiply the initial pressure and volume 1 multiplied by 2 and get answer 2. Similarly, if we multiply the final volume and pressure, that is 0.474 multiplied by 4.22, again we get the same answer, that is 2. Since both the values are same, therefore the data satisfies Boyle's law. Now at the end of this lesson, students, I am going to give you some questions for practice. Solve these questions according to Boyle's law and find out whether the data satisfies Boyle's law.